Let's take a look at another example of finding the equation of a line. This problem has a figure that is a circle centered at the origin, passing through the point 4, -3, with a line drawn through 4, -3 that is tangent to the circle at that point. Being tangent to the circle at that point means that there's a perpendicular relationship between the line that passes through the origin to the point, in other words, the radius, and the line that we wish to find the equation of. So the question says, find an equation for the line tangent to the circle x squared plus y squared equals 25 at the point 4, -3. So our first observation would need to be, how do we get the slope of this line? And the relationship again is, if the line is tangent to the circle, then it's perpendicular to the radius of the circle. And the radius of the circle passes through the center, 0, 0, and the point, +4, -3. And therefore, the slope of the radius, or radial line, is -3 minus 0 divided by 4 minus 0, or -3/4, and we check to see that that makes sense because the radius that we've drawn is decreasing from left to right, so its slope should be negative. This means that our line's slope must be the negative reciprocal of this value, or +4/3, and we see that that also looks correct. The tangent line is increasing from left to right. And since we already have the ordered pair that the line passes through, then we can quickly write the point slope form of the equation of the line as follows. Y minus the y coordinate of the point we're given equals the slope times x minus the x coordinate, or more specifically, y minus -3 equals 4/3 times x minus 4. We can clean it up a little bit. Y plus 3 equals 4/3 times x minus 4. And that is a perfectly good form of the equation of the line. And it's fine for our box. In our last example, we discussed whether or not there would be a y equals outside the box. That would determine how many options you have for entering your answer. So we can actually just leave our answer in point slope form. The part B of the question says, at what other point on the circle will a tangent line be parallel to the tangent line in part A? So the tangent line we've already found. Notice if we reflect the radius back through the origin to the left-hand side of the circle, we should find another tangent line that will be parallel to the line we have, and by symmetry it would pass through the point -4, +3. Notice the form in WebAssign here that is the xy equals parenthesis, and then there's a box, and then there's a closed parenthesis. So you need to type in -4, 3. But you don't have to type in the ordered pair parentheses as they were provided for you.